Great. So I'm going to go through the solutions here, everyone, to assignment number 24, which really highlights, let me just get this here out of the way, graphing sine and cosine with a horizontal shift there. All right, so number one is right here, and I got to start by taking the argument x minus pi and sandwiching that between 0 and 2 pi. And you're just resolving the inequality for x, and that's accomplished by adding pi to everything. So pretty easy there. And here we have it. So this is the beginning of that cycle, and this will be the end of that period. So then let's see here. I'm only up 2, so I should be okay. Pi and 3 pi. And what am I doing? Adding these ends. Pi and 3 pi makes 4 pi, and dividing it by 2, which is 2 pi. Then I'll add these two. Pi and 2 pi makes 3 pi, and divide it by 2. And then I'll add these two and get 5 pi and divide that by 2. All right, so some confusion comes in that when you're graphing this, 0 is not included in this cycle, but the 0, the origin is back here, everyone, and 0 is not part of this cycle. So when you begin graphing it, you got to begin here and end here. So the beginning is going to be up 2 because it's cosine, and we'll also finish at 2, while the very middle will be down 2. In the middle of the middles will be 0, if I could see things right. And there is no vertical shift. The amplitude here will be 2. The period is 2 pi divided by b, and b is understood to be 1, so it's just 2 pi. The maximum value is the highest y is 2. The minimum is minus 2. And the midline is y equals 0. It's the horizontal line that will cut the graph sort of in half. Number 2 is sort of like the same thing, except you just have x plus pi. So I'll take you through that here. I'm going to solve for x by subtracting pi from everything. And when I do that, 0 minus pi is minus pi, and 2 minus pi is pi. This is my new beginning. This is my new end. And won't that go away? So then negative pi plus pi is 0, and half of nothing is 0. I'll add these two, which is negative pi, times it by a half is negative pi over 2. And 0 plus pi is pi, and times it by a half is pi over 2. Unlike the previous problem, 0 is included in this cycle, which is the y-axis here. So in this one, we are going to be, we're graphing, what is it, sine? So the beginning, middle, and the end are 0. So the beginning of that cycle is actually at negative pi. And then that first half will be up 1 because that's assumed to be a 1, and the second half will be down 1. I'm going to dot that in, but I'm going to take care of that displacement, vertical translation down 2 units. So this is a kind of where, keeping things pretty neat. Down 2, down 2, down 2 more yet, guys. So that's going to take us down to minus 3 there. So that's going to take us down 2 more. And this is down 2 more. So it should be, pretty much even right across the board. And I could see that my graph. And again, these are very important points. We just can't turn around anywhere. It has to be in the middle of the cycle, the middle of the cycle. The beginning, middle, and the end are all 0. That first half is up, and that second half is down. In number 3, we got a couple of things to take care of here. So number 3, we're going to have to sandwich that inside stuff once again between 0 and 2 pi. I'm going to distribute the 2 through to make things a little easier. And so I'm just going to times everything by 2. I'm going to subtract 2 pi from everything. And and I subtract 2 pi, I get negative 2 pi, and 2 pi minus 2 pi is 0. Then I divide everything by 2, and then I'll get negative pi less than or equal to x less than or equal to 0. And now I got my new beginning and end, which is minus pi and 0. And this is the y-axis, obviously. I'm going to add these two and get negative pi, and times it by a half is negative pi over 2. When I add these two, I'll get negative pi over 2 times 1/2 is negative pi over 4. So you can see you're counting by negative 1/4, negative 2/4, and then finally negative 3/4. And then it's up 1, 2, 3, 4. These are nice when you have a good grid. So this one here, I got to handle two things. It's going to be cosine is going to be up 2. So the beginning here is up 2, and the end of this cycle is going to finish at 2, while the very middle is down 2, and the middle of the middles are 0. And then finally, I'll take everything down 2 units, down 2 units. So you should see everything, guys, being nicely evenly displaced. It's a vertical translation down 2 units. There we go. And number 4 is a good one, especially with the fractions. So I'm going to sandwich the x minus pi over 2 between 0 and 2 pi. And we've been, talking about how we clear away fractions in an equation. We multiply through by the least common denominator, which in this case will be 2. This will give me 0. This will give me 2x. These 2's will divide out. And then 2 pi times 2 is 4 pi. I'm going to add the pi to everything. And then divide by 2. This is the new beginning, and that's the end. So when I come over to here, it's pi over 2 and 5 pi over 2. And again, I'm just going to add the ends. So a half plus 5/2 is 6 over 2, right? That's 3 times a half is 3 pi over 2. And then 3 plus 5 is 8. Divided by 2 is 4 pi. Times 1/2 is 2 pi. And then 1 pi plus 3 pi is 4 pi. Divided by 2 is 2 pi. Times a half is pi. So keep your focus here. The origin is way back here, and that's not part of this cycle. So I think I'm graphing here what? Sine. So the beginning, middle, and the end are 0. I'm not putting this at 0 because 0 is not part of that cycle. This is the beginning, middle, and the end of that. And then the first half is up 1, and the second half is down 1. And I do believe I have a vertical translation of up 1. So everything is going to go up 1 unit. And it's going to look like that. So in this one here, the period is 2 pi divided by b, and b is the number in front of x. So that's just a 1, so the period is 2 pi. The amplitude is y equals 1. It's the constant. I'm sorry, no. The amplitude is 1. But I looked at the wrong one. It's this one. And the midline is y equals 1, which is the constant. And the max here, the highest y, is 2. And the min is 0. So if you come down here to the graph, the highest y is 2. And the lowest y there is 0. All right, and the rest are all old problems if you want to stay tuned. Number 5, I got to do that difference quotient on that polynomial. So it's 3x squared minus 5x plus 3. So guys, when you're doing this right here, this means the function evaluated at x plus h. So it's 3 times x plus h squared minus 5 times x plus h plus 3. And this part means to do minus the function. I guess I can take those away because I already distributed it, right? So this is the part some people are missing. We have to do minus the function. So that means I take this function f, which is right here, and times it all by a negative, which is minus 3x squared plus 5x minus 3. And this FOILed out is x squared plus 2xh plus h squared. The thing I distribute the 3 through that, right? And then distribute the minus 5. And then now the x squareds will add to 0. The x's add to 0 and the 3's. And this is what I'm left with. Just that. Everything without an h did add to 0. All right, what's next here? Just some old problems. Great problem is number 6. Just put this in separate paper here. So number 6 here, it's already set to 0. I'm going to try and see if I can reverse FOIL that into 2x and x. And I think I'm going to need a 3 here and a 1 here. Let's see. No, it's not going to work there. It's going to work here and here. 3 and 1. Minus and plus. And the reason being is you got to check the outer and the inner. 2x times minus 3 is minus 6x plus 1x is negative 5x indeed. And then remember, we have to do that number line test. Anytime you're doing one of these, you need that number line test. And those critical points are, well, if I can order things right, negative 1/2 and 3. If I pick, say, negative 10 as a test point, I'll get negative 19 times negative 13, which is a positive. And because these powers are odd, it will alternate. Where am I greater than 0? That's where the number line is positive, and that's where I'm shading. But that shading is not the answer. It just helps me to write my answer. So where's the shading at? It's from negative infinity to negative 1/2, and then from 3 to infinity. And this one here, number 7, 5 pi over 6 puts me right here. And I'm trying to be lazy here, not to write that everything all over. This is 1, negative root 3, and 2. Cosine is x over r, so negative root 3 over 2. Sine of 0 puts me here. The y coordinate is 0. And negative pi over 4 kicks me down here, guys. It goes clockwise. 1, 1, and root 2, but that gets the negative. Tangent is y over x. Negative 1 over 1 is negative 1. And we got to just reinforce that factoring. So number 8, I always start with the GCF. And what's left is x cubed minus 8. But that's a difference of 2 cubes, which a lot of us are remembering very nicely. Take the cube roots of both. Sign in the middle goes in the middle. Square it. Multiply, add. And then plus 4. And this one over here, we got to take out an x again, everyone. But what's left is 4x squared minus 5x minus 6. Reverse FOIL that. Don't give up. So, I don't know. I'm going to try. 2x and 2x gets me 4x squared. But I need factors of 6 here. Let's see here. 3 and 2, I know. But no way is that going to give me a 5 there. And switching the 3 and 2 around is not going to work. So let's do 4x and 1x. See how that works out. Okay, so this much gives me 4x squared. Now 6 I need is 3 and 2. So if I put a 2 here and a 3, these do multiply to give me a 6. So I'm going to try the negative here and the positive here. Again, check that outer and inner. The outer is negative 8x. The inner is positive 3x. And that does give me negative 5x. So then this is my answer. Those are my answers right there, factored. All right, everybody, I hope that helps you there. Just definitely have to keep brushing up on that factoring, especially that reverse FOIL, where you have to check the outer and the inner, that they do combine to give you that middle.